This call is now being recorded.
Okay, it is lesson 14, Algebra 1, Module 1, and we've been spending a lot of time with solving equations, justifying each step of the equation using our number properties, the distributive property, properties for equality with addition, subtraction, division, multiplication. And so today we get into what's called solving inequalities. In other words, with the less than or greater than symbol. And we're going to get right to how it's different and how it's similar to equations, solving equations. And so lesson 14, you're going to learn the if-then moves using the addition and multiplication properties of inequalities to solve inequalities. And then you're also going to graph the solution sets on the number line. All right, so a lot of things coming together here. You should see a lot of similarities in what we're going to do now in lesson 14 and what we did in solving equations in the previous lessons. Here we go. So we start with, in your book, if you want to follow along in your book, or if you just take notes with your notebook. Example number 1 in the book for lesson 14 says, what is the solution set for the inequality or to the inequality 5q plus 10 greater than 20? And it says express the solution set in words, in set notation, and graphically on the number line. So we're going to look at that with regard to performing our work here in lesson 14. Here we go. So the first thing I'm going to do is treat it just like an equation, basically. I'm not going to treat this hardly any different than I would a regular equation. So I'm going to want to just rewrite it, and from the beginning, I notice instead of an equal sign, I have a funny little symbol. This is called, it's good to know the difference. This is called greater than. And then of course, we know if it's reversed, this is called less than. And because we read from left to right, that's why we say greater than for the top one and less than for the bottom one. And then if we said, well, what if there was an equal sign here and here? Then you would just simply add greater than or equal to. And so if you see this line here attached to those things, it's red or equal to. All right, so that's a review of the inequalities. In this particular problem here, we're going to solve for q. My first step is to say what's happening to this part right here. Well, I'm adding 10. Just like an equation, I'm going to subtract 10 to both sides. And I notice that what I get is I still have the 5q. It's still greater than 10. So the subtraction property was the first step. Second step, what's happening to q? Well, I'm multiplying by 5. What's the opposite to multiplying by 5? Well, that's simple. Divide both sides by 5. And you get the answer of q greater than 2. So in words, the solutions are all real numbers where or such that q is greater than 2. So there's in words. In set notation. So all real numbers, and so q, and we could say all reals, they're real, such that little line right there, and then it's simply just put q greater than 2. And so that's in set notation. We'll do a review of that. And then finally, and in green, we'll designate what's it look like on a number line? Well, we keep it simple, and we just put whatever number this is, put that in the middle, and then normally it gets bigger as you go to the right, so we're going to put a 3, and you're going to put a 1 here. This is what I would do. Since q is greater than 2, it's not equal to, and so that circle is going to be open. This is going to be an open circle. Open, because it's not equal to. And then when I go to shade, I'm shading to the right because it's greater than. And so there is what we're going to end up doing to all of our inequalities in this lesson. Okay? All right, let's go to some more practice problems. Pause the video, make sure you get that down. That completes example number 1. Number 2, we're only going to do 2 problems, A and B, even though I have C there. So here we go, next problem. Find the solution set of this inequality, express the solution in set notation and graphically on a number line. So this time we have to write it in words. So we're going to read the directions and that minimizes, and we're not going to do, for right now, we're not going to do C. So let's start with solving A. And the first thing I notice here is I'm going to just simply say what's happening in X, so I'm adding 4. What's the opposite to adding 4? Just simply subtract 4. And so I get X is less than or equal to 3. So there's my solution. Now again, I've got to write it in set notation and a number line. And so in set notation, I'm going to go ahead and write X, all reals, such that X is less than or equal to 3. And the little set mark right there. So that's, remember, I'm just spelling out real there. X is real such that X is less than or equal to 3. And then finally, the number line answer, keep it simple. Put the 3 here, put a 4 here, and just put a 2 here. Space it out. And then it is equals to, and so we're going to have a closed circle, and it's less than, so I'll do that in black so you see it. And we go this way. Just scribble this way. All the values this way are solutions. So that's the solution to A. B, you notice something different. It says M divided by 3 plus 8 is not equal to 9. So let's see how that is different than what we did in A. We're going to solve it the same way though. The first step, we're just going to solve it. We're going to ignore that for right now, and we're going to subtract 8 to both sides. And I get M over 3 is not equal to 1. Again, notice, focus on what we did here. We just said, let's get rid of this, and what we do on this side, we must do on this side. And that left us with the M over 3, and of course, this doesn't change. And let's keep solving. The next step, since I'm asking what's happening in M, well, I'm dividing by 3. What's the opposite dividing by 3? Multiply by 3 on both sides. And that's why we get M is not equal to 3. Okay, so how do we write that in set notation and on a graph? Let's take a look. So in set notation, I'm going to do the same thing. M is real such that all reals where X is not equal to 3. That's how simple this is. That's in set notation. And then graphically, we would just write the same thing we've been doing. Put the 3 there, put a 4, put a 2, and then look. All reals except 3. So we're going to have an open circle. And then everything here is shaded and everything here is shaded. The only thing that's not a solution is 3. So everything around it. And that concludes A and B. Now, we're going to finish this out with, you can see that we're doing exactly the same thing with equations. Example 3 provides a slight difference. And so we have to be careful with the next couple of problems I'm going to show why you have to be paying attention. So this problem, you see actually looking at eventually dividing by a negative number on both sides. Okay? And this is where I need to make sure that you are paying attention. Pay attention to that right there. Because if we typically would solve for this, we would divide both sides by -1. And I'm going to show you two different ways to look at this. The first way is the book does this in the workbook. Rewrites the problem. And what the book does is it actually moves things around. So it's going to add Q to both sides. And you get 0. And then it's going to add 7. And you get 7 is greater than or equal to Q. So this is actually the solution. Now, I want you to watch carefully, because if you're not paying attention, and let's say we didn't pay attention, so it's really important that you're paying attention now, because if you divided by a -1 and you just put Q is greater than or equal to 7, notice this does not equal, these are not the same. So which one is correct? The first one. So in this case, and this is one we're going to spend quite a bit of time on, this one would have to be switched from this symbol to this symbol. And now you can see, now they are the same. Now they're the same. So what am I saying? Well, when you multiply or divide by a negative number, those two operations, by a negative number, the inequality sign has to change. Let's do one more so you see it. In fact, it shows it here. I'll let you take a look at that. It shows the key idea is if A is greater than B, then K times A is less than K times B for any negative real number. And that's what I just said. Multiplication and division are the same. So if you multiply or divide by a negative number, it's going to switch the signs. And in your book, number 6, here's the solution. You want to go back and take a look at it. I would highly suggest that you really analyze the difference in how they produce these two problems. Why they chose -1/2 to multiply, I don't know. Doesn't really matter. But you can see they get the same answer. In one way, they're moving things around with addition and subtraction. In another way, they're multiplying by a negative number. They switch the signs.